Okay, now we're on day 4 of combining our rules. So we're going to have to make sure we know all our rules so we can combine all the different steps and solve these complex problems. Okay, so for this first problem here, I'm noticing I've got a bunch of coefficients and variables all with the 5th power. And then here I've got some stuff with the 0 power. Okay, so I think what I'm going to do is give everybody in these first set of parentheses the 5th power. So 2 gets the 5th power, and x is going to get the 5th power, but it already has a power. A power to a power is so powerful we multiply. All right, now I have to multiply. This set of parentheses, everyone gets the 0 power. So 4 gets the 0 power, and then x gets a 0 power, but he already has a power, and a power to a power is so powerful we multiply. 2 times 0 is 0. Okay, now we'll do some calculations. 2 to the 5th power, so go ahead and make sure we type that in. 2 to the 5th power, and the answer is 32. Okay, so that becomes a 32 coefficient. This is x to the 15th power. What's 4 to the 0 power? Let's see, 4 to the 0 power, that's a number I can calculate. Well, that's right. Anything with the 0 power becomes a 1. Okay, so that just becomes a 1. And then x with the 0 power, same thing, becomes a 1. 32 times 1 times 1, the answer is 32x to the 15th power. Okay. It says do it a couple different ways. I guess the only other way I could have done this problem was early on. You could have noticed that this entire quantity right here had a 0 power. Okay, so what I could have done was just focused in on that right there. Anything to the 0 power, that entire quantity could have became a 1. And then I could have focused on this separate. So then what I would have done was give 2 the 5th power, give x the 5th, a power to a power so powerful I multiply, and I don't really need to say times 1. And then we would have calculated 2 times 2 times 2 times 2 times 2 and got 32x to the 15th power. Okay, either way you're using the same rules, maybe just in a different order. Whatever's easier for you. If you like to see everybody get the 0, go for it. Okay, for this next one here, I see a couple of rules. Okay, I see a quantity that's getting squared. Okay, and who's that squared power going to go to? Is 2 going to get squared? Yes, of course. Is x going to get squared? Yes. Okay. Is this x out here going to get squared? No, sorry, you're not really part of the deal. Okay. All of the things inside of this set of parentheses get squared. So 2, you're going to get squared. X, how do I square you if you're already being cubed? A power to a power is so powerful we multiply. And then I've got x to the 4th. Okay, you could put dots to say times, or you could put nothing. So let's calculate. 2 times 2 is 4. Can I combine all those x's using a rule? Lots of x's. What do I do to those powers? It's not a power to a power. Those you would add and say 10th. Okay. Now, what's another way you could do this? If you're forgetting the rules or the rules are getting complicated, what we could do is do it the long way. I could write 2x cubed, and squared means I have to write it out 2 times. And then I also have times x to the 4th. So if you don't like the rules, remember, you could always do it the long way, figure this out. So I've got 2 times x times x times x times 2 times x, and then there's 4 more x's. So 2 times 2, I know the answer is going to be 4. And how many x's is that? 4 of them, 5, 6, 7, 8, 9, 10 x's. Okay, if you always want to check something on the test, you could write everything out and then add them all up and see how many there are. Okay. All right, let's keep going. On page 17 here, this was the rule with who gets the power, the numerator or the denominator? And the answer is everything. Okay, both of them. So is the 2 going to get the third power? And the answer is yes. Does S get the third power? Yes. How about in the denominator? Should 3 get the third power? And how about T? Should T get the third power? Okay, and then we had this other fraction over here, which was T to the 5th over 16. Okay, so I got a lot of numbers. Maybe we should calculate all the numbers. Okay, so please use your calculator because I'm seeing lots of silly mistakes just with the numbering. Okay, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. I'm going to write times 16 closer to him. Okay. And then we have S to the third power. Now what about these T's? What about these T's? There's more T's in the numerator. There's more T's in the numerator. So I think what I'll do is say T to the power of 5 minus 3. I'll subtract them. You do 5 minus 3. If you needed to see this the long way, this would be 1, 2, 3, 4, 5 T's there, and there'd be 3 T's down here. So how many T's would be left? I think there'd be 2 T's. Is that what we're getting? Perfect. It's making sense. Don't forget when you have numbers, okay, with your calculator, you could always do alpha y equals. The fraction's 8, the denominator is 27 times 16, okay, and it will simplify to 1 over 54. So it will simplify everything for you. Okay, so our fraction is 1 over 54. We have S cubed, and we have T squared. You don't even really need the 1 if you don't want it. Okay, don't forget, if you have a calculator, which you should, okay, and you do alpha y equals, we could even type 2 cubed over 3 cubed times 16. Okay, and it would do all the calculations for you, just to make sure we don't make a little error right there. Okay, now what would have been another way to do this? Not that much different. But let me show you how some people like to do it. So you still have to give everybody the third power. Okay, so you're still going to have 2 to the third power, S to the third power, 3, you get the third power, T gets cubed. Okay, everyone's got to get the third power. There's no variety there. Okay, and then times, we have T to the 15th over 16. Okay, so the only other way I would maybe suggest doing this, the numbers are going to come out the same. The 8, the 27, the 16. So I know that's going to make 1 and 54. I'm just going to skip that work because we just did it. We've got S to the third power. Now what about these T's? Okay, maybe what we could do instead is put them together. Put them together. There's, oh, why did I write 15? This should just say 5, right? Sorry. Okay. Maybe I'll put all of them upstairs. If I bring these T's upstairs, their exponent becomes negative. So is that going to be good? T to the 5th times T. When those T's go upstairs, the power becomes negative. I guess I could bring these 5 downstairs, but then 5 is going to have a negative power. I'd rather have the smaller number with a negative power. Okay, so how does this work out? It should work out the same, right? We have S cubed. 5 minus 3 is T squared over 54. Okay, so you could always bring them up to the same level and then put them together. Okay, this last one right here. This last one, we have, a set of parentheses, and everything is getting cubed. Okay, so we're going to have to cube the 3, and the x is going to get the power, and the y. Everyone's going to get the power. Okay, so let's write 3. You get the cubed power. X, are you going to get the cubed power? Yes, but you already have a power. A power to a power so powerful we multiply, make -6. And y, same story with you. Power to a power so powerful we multiply. Now we're not done. We can't leave it like this because I see some negative exponents. So it's time to draw a fraction bar, and we're going to have to talk about who gets moved. Okay, does 3 have to move downstairs, or does he stay upstairs? How do you know? You look at the power. The power's positive. We're going to keep them upstairs. X, what about you? You're going to get moved downstairs. And then your power from -6 changes to +6. What about Y? His power is positive. Should he stay or go downstairs? He should stay. Okay? Does everybody have to move? No, you look at them one at a time. If somebody goes downstairs, does somebody have to swap and come upstairs? No, they're all independent. Okay, the only thing left that we have to do is calculate this number right here. So 3 times 3 times 3 is 27 y to the 6th over x to the 6th. Okay, how else could we have done this problem? This is the most popular way. This is the most popular one. What we could have done instead, though, is right away in the beginning said x, I'm going to move you. So you could have said 3 y squared is going to stay on top. And then x, let's move you downstairs and make your exponent positive. Some people like to move first and then give everybody a third. This is the more popular way. So I would suggest give everybody their power and then just move who needs to move. Okay, but this would work out the same way. So we would have to give 3 the third power. Y would get the power. Power to power is powerful. X would have to get the power. And you're noticing, we're getting the same answer. Okay, I just think that the first one is a little clearer. Okay, but either way you want to do them. Okay. All right, this is how we put all the rules together very clearly, making sure we don't mix them up. Thanks, guys.